Hey AP Calc. This video is going to be on section 1.3. It's the third lesson we're talking about, and it's all going to be about trig proof and solving trig equations. Now that was a pretty hefty undertaking when we did it in pre-calculus, but today I really just want to kind of make sure that we understand the textbook type examples of what they're kind of expecting from trig proof and solving trig equations, and then tomorrow I'll have some videos where we're going to be solving stuff from my pre-calc material that I think maybe could be a nice little supplement to what they're giving. All right, so this will give us the complete package. This is the last kind of lesson that we're dealing with over the next 2 days, and let's get to it. So when you see this, it says prove that 1 minus sine squared times 1 plus tangent squared equals 1. You've got a couple different strategies. The first strategy is to turn everything into sines and cosines. That seemed to be a pretty good one for people just if they didn't know how to start it to move forward. There's one thing I noticed though. It's that if you've got squared trig functions, we had 3 identities that pretty much gave us like the go-ahead to move forward. And this would be one of those problems where you're like, let's investigate a little bit and see actually what we're trying to prove. So this whole thing is trying to prove down to 1. So either something's going to be divided by itself or multiplied by something that is very, very similar to it. Or terms are just going to start canceling left and right. So when I take a look at this, I instantly see that 1 plus tan squared equals secant squared is literally one of the parts that we have on the left-hand side of the equation. So when we're proving, we can only manipulate one side of the equation at a time. So 1 plus tan squared can be replaced with secant squared x. So this is now gone. This is in its place. So we could rewrite 1 minus sine squared by the way, these are t's. Let's keep them the same. But on second thought, we're trying to get 1 here. Wouldn't it be nifty if secant squared could be multiplied by the thing that makes it 1? 1 over secant is cosine. So when you multiply when you multiply cosine times secant, all right? So think of it just like as a quick multiply both sides by secant. This shows that the secant of x times the cosine of x is equal to 1. And that would work if they were both squared, because you could square both sides. Secant squared times cosine squared equals 1. So the question is, I have secant squared. Is this cosine squared? 1 minus sine squared? And the answer is yes. Because the identity sine squared plus cosine squared x equals 1 can be manipulated by isolating cosine squared by itself. So 1 minus sine squared is cosine squared. So this becomes cosine squared of t. Now I kind of proved over here that cosine squared times secant squared is equal to 1, but if you want to kind of keep your proof organized in such a way that the reader could easily read it from start to finish, I will be the reader, so maybe you should do that. You can say, hey, cosine squared times 1 over cosine squared. That works out. And then at that point, you can say that this is cosine squared over 1 times cosine 1 over cosine squared becomes this, which equals 1. That's pretty thorough algebraically when you show all of those steps. Okay? So the lesson learned from this one is be constantly looking at your identities. Don't just randomly turn everything into sines and cosines and expect yourself to get to the finish. Because I actually worked it out that way, and it took a long time to get back to the starting point, and then it just was messy. So we got another one, number 47. So you got cosecant squared theta over 1 plus tan squared theta. I mean, we're staring at another one with identities written all over it. We're trying to set it equal to cotangent squared of theta. The question is, should we manipulate the bottom, which is 1 plus tan squared theta, which we know is secant squared, we just used that in the previous proof, or should we manipulate the top, because I know the top cosecant squared and cotangent squared are connected with this identity. I think it's probably going to be less work if we just take 1 plus tan squared and turn it into secant squared. All right, so this part here is gone, replaced with secant squared of theta. Now, I don't know if messing around with the identities at this point is our best bet. It might be, but I also know that maybe we could do the thing where we turn things into sines and cosines, because we've got a square and a square. So if we turn them into sines and cosines, the squaredness of it will be retained. So cosecant squared is 1 over sine squared. Secant squared, and instead of putting a big division symbol, I'm just going to rewrite it horizontally. You can do that. Divided by secant squared, which is 1 over cosine squared. Now I'm feeling pretty confident about that because cotangent can be written in terms of cosine over sine. I see a cosine and a sine, and I see pretty simple division going on here. So keep, change, flip, or flip the second and multiply. However, you need to remember that. Times cosine squared over 1. And then when you multiply fractions, you multiply straight across. And then cosine squared over sine squared becomes cotangent squared. So that works. Let's try it the other way. So the other way was changing the cosecant squared into cotangent squared theta minus 1. All right, if you look at that formula sheet, that is how you can manipulate the identity 1 plus cosecant. Wait a second. Let me check out that. Yeah, it's 1 plus cotangent squared equals cosecant squared. Isn't it? Right when I take down the formula sheet is when I need to verify it, right? So it's 1 plus cotangent squared over 1 plus tan squared. Now, that's not looking like a good route at this point, because all I can really do is, go back and use secant squared here, or I could turn things into sines and cosines and keep moving forward. I wonder if I turn the bottom into secant squared of theta, like I did on that first one, if this will do it for us. Because you can split the fraction up into 2 parts. Which this is the same as cosine squared. which this is cosine squared over sine squared divided by secant squared. Times 1 over secant squared. But secant squared is the same as cosine squared if it's flipped, which it is. So that route doesn't really, we can still do this. I can still factor out a cosine squared from these. And get 1 plus cotangent squared. Because cosine squared over sine squared is cotangent squared. I'm skipping steps now. That would be cosecant squared times cosine squared, which does get us to there if we do a few more steps. Not a successful way to do it because it added probably way too many steps than we needed to. But it will eventually get you there. And that's the thing with trig proof, is that even if you get lost, you just keep following the path of logic and it should get you to the final answer. Let's check out number 49. I think we have just enough time for that one. Gives us some Greek symbols to work with. That's always fun. We've got 1 plus cosecant of beta divided by secant beta. And you subtract cotangent of beta, and that should be cosine. So my gut instinct is to split up this fraction. Since it's not squared, I can't do any identities. So that's 1 over secant of beta plus cosecant of beta divided by secant of beta minus cotangent beta. So right away, I recognize that this is cosine. So I'm hoping that this will end up being cotangent. So that's what I'm gonna work for right now. I'm gonna rewrite this as cosine of beta. This is going to be 1 over sine of beta divided by 1 over cosine of beta. And I'm just going to keep this as cotangent. So flip the second and multiply. Times cosine over 1. And yeah, this will be cosine over sine. Which, you know what? If I wanted to kind of like make this proof go a little bit quicker, I could have rewritten the cotangent as cosine of beta divided by sine of beta. Because then they'll cancel out earlier in the problem. You got cosine of beta over sine of beta. Cancel out. These become 0. And you're left with cosine of beta.